There's been a bit of a conversation about artificial intelligence lately, and I think it's useful to remember that this is not a new term. The term was actually coined in 1955 by John McCarthy, who was a scientist, and he coined it to convince the US military to give him money. So artificial intelligence, actually a marketing term designed to raise money. Now, most of us didn't hear that term then. Most of us weren't alive in 1955. By the way, he was successful. The US military gave a bunch of money to build a system for doing logistics for the US military. And it worked pretty well, and then they stopped giving him money. The first time the public hears the term artificial intelligence is in a movie from 1968. The movie is called 2001: A Space Odyssey. I recommend this movie, although there are no words spoken for the first 28 minutes. But there is a character in that movie called Hal, and Hal promptly tries to kill everybody, establishing our relationship with artificial intelligence, at least in science fiction. 20 years later, Terminator. And 20 years after that, Ultron. This is not a good term. It's a very tough way to think about software. In the end, that's what we're doing, is building software, because it's so steeped in science fiction. And while there's been many iterations of artificial intelligence over the years, the current iteration starts with a few key events. And I'm going to focus on a professor by the name of Geoffrey Hinton from England, got his degree in artificial intelligence in 1977. And he was firmly on the neural net side of artificial intelligence. That's the area that he explored in. And in the 80s, he built a few cool bits of technology that went on to do things like recognize postcodes on envelopes and dollar amounts on checks. He realized that neural nets could only go so far in the 80s. He wanted to build deep neural nets, but ones that had many layers of computation in them, but it was too much for the computers at the time. And so while he wrote some important papers, not a lot got done with it. They did able to do those simple things about letter recognition, but much more than that wasn't really possible. But fast forward a few years into the early 2010s, and a set of his students set their sights on an image recognition competition called the ImageNet competition. So this was 14 million images, largely taken from social media. Thanks for your data. And they were labeled. They were all described as to what was going to be on them. And your goal, if you wanted to compete, was to write a piece of software that could look at those images and rewrite that caption. That was the task. And that competition started back in 2011 or 2010, and the success rate was really low, maybe 50%. But it was Hinton's students, including Ilya Sutskever, that implemented a bunch of the ideas that Hinton had back in the 80s against a large, deep, convoluted neural net trained on a large number of images. They entered the competition in 2012 and got 84% right. And 2 years later, it was 100%. So by 2015, what was once impossible, this idea that I could take a photo with my phone and my phone could tell me what was in that photo, is now normal. We've forgotten in 10 years that it's impossible. These technologies have become normalized already. Now, this wasn't the only area. It wasn't just Hinton's team. There was a bunch of emerging technologies all at once. One of them was coming out of the Stanford Research Institute, or SRI. They were focused on voice. Now, voice recognition had existed for a couple of decades before that, but it wasn't very good. Maybe a 90% accuracy rate. If you wanted to play with a Dragon naturally speaking board or any system like that, you would have to train it yourself. So after you got it all set up on your computer, you'd get the microphone and you'd repeat phrases over and over again until it was correct. And SRI thought that with the new generative AI models that were possible today, and then the amount of recorded voice that was available, that they could actually pre-train a model to be right every time. And they succeeded. And as soon as it was demonstrated, Apple bought it, added a letter to the name, and called it Siri. And all of a sudden, your phone could recognize your voice, unless you had an Australian accent. Didn't do enough training over there. So a bunch of different areas happened all at once in generative AI, largely due with the compute that was available and the sort of ideas that were emerging at the time. They were mostly science ideas that became a few products. Now, Hinton and that Sutskever with him as a student were encouraged by Google to form a company to commercialize some of the ideas they developed with large convoluted neural nets. And then Google immediately bought it in 2013, making them all fairly wealthy and moving them down to San Mateo in the Google headquarters to be part of a group called Google Brain. Google Brain had been formed in 2010 to sort of pull together the best minds working in generative AI. And this was about the time when a lot of folks got really nervous about what Google had accomplished, the technology that was starting to emerge in there. You may remember this around 2014 or so, when folks like Bill Gates and Elon Musk and even the late Stephen Hawking said, hey, artificial intelligence has a huge amount of potential here, and it's largely being controlled in private, and it should be done in public. It should be more visible. It should be shared with the world. It shouldn't be a competitive technology. And then a group of billionaires got together and formed a company to do artificial intelligence in the open. They called it OpenAI. So this is Elon Musk, Peter Thiel, and Sam Altman and Reid Hoffman, a bunch of Silicon Valley billionaires, saying they were going to fund this group and all the scientists should come work for them. This is the place where it was going to happen. It's just that they lied, didn't really actually fund it. I mean, even Elon even recently said that he put $100 million into OpenAI. It's just not true. He put $16 million in and 8 Teslas, but that wasn't enough money for them to really do all the things that they intended to do. So OpenAI almost wasn't designed to succeed. It was designed to pull all those really brilliant minds into one place, separate from any big multinational corporation like Google. But the technology was doing some things, and our friend Jeff Hinton, back in 2016, made an announcement. He was talking about how good image recognition had gotten now, and he said, the career of the radiologist is over. That you'd be a fool to be a radiologist now because the software could do image recognition for medical issues like cancer and other things that can be seen in MRI scans and CAT scans and so forth. There's just no need for radiologists. He was completely wrong. You know, he's a fine computer scientist, and I suspect there's a Nobel in his future, and we're going to remember him. But he's not an economist. And actually, the demand for radiologists has gone up, not down. Because as radiologists were able to do more using these tools, there are 700 different models now certified by the FDA for doing recognition of health conditions. And so radiologists can move much more quickly through the process of identifying potential illnesses through these scans. And the result is many more scans are being done. That the demand for scans was always much higher than the ability to process them. And so the automation opened the door to 3 times more scans. Unfortunately, you can't grow radiologists as fast as you can grow software. And so the demand for radiologists is up, but the training takes time until it takes a qualified person using the tool to show the results. So appreciate computer scientists. Economics are more complicated than that. And our technology was still moving forward. Image recognition is a remarkably solved problem in this space, but it's not the only one. Meantime, over in OpenAI, they were limping along with a limited amount of money, and their original product was a universal translator. What they were trying to do is tokenize any language so that they could spit it back out in another language. And along the way, they discovered that actually it was a fairly good language predictor as well. And so they published GPT-2 back in 2019. Now, they made a bunch of different sizes of it because they were so broke, they couldn't even afford to run their own model at full size. So the smaller ones were for testing, to try and save costs, minimize the expenses around all this. And it was about that time that Kevin Scott, who used to be the CTO of LinkedIn, but then when LinkedIn was acquired by Microsoft, was on a mission. He worked for the office of CTO, and his job was to find workloads for Azure. Didn't really care what they were, just find more workloads for the cloud. The cloud is about 10 years old. The easy conversions are sort of done. Time for new workloads. And Kevin Scott came from the Silicon Valley. He knew that space very well, and he talked to the OpenAI guys, and he saw the situation, and he wrote a now fairly famous email to Satya Nadella, where he said, look, I think these guys are on to something. It's probably a long way away, but all of this work could be done on GPUs in Azure. Why don't we invest in them? And so Microsoft basically made an offer to OpenAI. We want you to restructure your company to allow investment. We're going to invest $1 billion into you, and you're going to spend that on Azure. This is a pretty good deal for Microsoft. I make $1 billion investment in a company, so there's $1 billion investment, and then I get paid $1 billion in Azure consumption. I just made $1 billion into $2 billion. But it also opened the floodgates for OpenAI to move faster, to start hiring more people and building more software and pushing on the potential of what the GPT could be. And around that time, they published a paper. This is in 2020. They called The Scaling Laws of Neural Language Models. The names on this paper are extraordinary. You could look it up if you want to, but they include folks like Jaron Kaplan, even Dario Amodei, who's now the CEO of Anthropic, were part of this paper inside of OpenAI. And what they said is that everything you know about machine learning is wrong when it comes to natural language models. See, in machine learning, we'd learned a long time before, especially in things like image recognition, not to overfit. That you could train the model on a data set, but if you tried to get close to 100% prediction, it was so overfitted, it wouldn't work for anything else. But this paper said, that's not true for language. If we get bigger data sets and train it on more, as much language you can find, at some point, it'll just accelerate. It'll get extraordinary. So give us more money. It worked. In fact, the back of this entire idea around LLMs kind of comes from this paper. And from that $1 billion and a whole lot of Azure utilization, GPT-3 emerged, a larger model, again, 375 billion parameters, training on more and more text on the internet. In fact, this is in 2020, right? During the pandemic, Microsoft hyped the whole thing about how they built the 5th largest supercomputer in the world out of a bunch of Azure data centers, 285,000 CPU cores to process this model. And it was still terrible. Now, the GitHub guys grabbed a hold of this and said, hey, maybe if we get away from human languages and talk about programming languages, maybe this will work a little better. And they gave it a great name. They called it Copilot, which has all the implications you need. It starts with, you're the pilot, still your fault. It's also a really good name, so you know Microsoft didn't think of it, but they'll certainly use it a whole bunch. Now this is 2021. And the OpenAI guys kind of go back to the drawing board on GPT-3 and say, like, how do we make this better? And they come up with this idea to do second-order training. And so in second-order training, what they're now doing is asking the existing model a question and getting back 4 results. And then a human would rank the results. And from those rankings, they would build another set that would help tune the model. The problem is, because it was so heavily overfitted on so much data, typically every possible partial sentence or every question that you could present to the software presented 3 or more answers. And so using second order ranking allowed them to sort of discern down to a better answer. Now they tried to do this as inexpensively as possible because they only had $1 billion, although they convinced Microsoft to kick another $2 billion in. And so by the fall of 22, they'd run out of money again. The training sets were done in the Philippines, in Indonesia, anywhere where they had low-cost English-speaking people that could work through this process. And so ultimately, their answer to being short on money was to make it public. And in November of 22, they put out ChatGPT. It was an experiment. It wasn't a grand solution. What they didn't expect is for 100 million people to sign up for it in 2 months. In fact, they were so unprepared, it just about broke Azure in the process. I've talked to a bunch of folks that worked inside them. They didn't have a Christmas in the fall of 22 because all they were doing was trying to scale Azure as so many people signed up for this. I had an opportunity to talk to one of the scientists at one point and said, why do you think 100 million people signed up this quickly? And he says, I think it's because we shipped it over Christmas and people would rather talk to software than their loved ones. But the reality had happened, and by January of 23, we have the least amount of time to 100 million users in history, and that's a trigger point. This is where we get into this idea of an AI bubble. Now, we've been through the hype cycle before. Gartner Group coined this concept, and they were originally talking about things like the dot-com boom, where the technological trigger for the dot-com boom was the IPO of Netscape. that was the kickoff point for a huge amount of money funneling into this idea of the World Wide Web and all that potential. Inventing the technology was the important part. You had to have this moment of engagement, this expansion that then overhypes everything to the point where eventually we see it can't do all of the things. And then you go sailing down that trough of disillusionment. Now, the technology doesn't go away. 2001, when the dot-com boom was over, the web was still there. In fact, one would argue the most important thing that happened in that period from 97, when Netscape IPO'd, to 2001, when the bubble burst, was all of the undersea cables that were laid, which is a talk I'm doing later this week, because all of that cable still existed. And the byproduct of the dot-com boom was all that cable went bankrupt and was bought up for 10 cents on the dollar, and now you have call centers in India because it's cheap, because connectivity is inexpensive. So we build out infrastructure on the backs of these bubbles and then take advantage of them in the post. That hasn't happened yet. We're at the beginning of this, at least in 2023. So the first thing Microsoft does is hijack the Copilot name and attach it to Bing, because that's a good idea. And then they move on from there to call everything else Copilot. Actually, what really happened internally in January of 23 is that Satya Nadella, for the first time in his career as CEO, sent out an all-hands email. This is something Bill Gates was famous for, the internet tidal wave, trustworthy computing. These were Bill Gates missives that literally turned the company on a dime. And now Satya had done it. What he said was, here are the OpenAI APIs. Every team needs to implement a Copilot. That is too many Copilots. Now, most of them we'll never see, and we're probably better off for it. But think of the brilliance of this. He took 200,000 people, at least 80,000 engineers, and had them all study the API and experiment with it. And then bring forward all of the ideas internally that they'd come up with. Some of them are going to be important. I don't think M365 Copilot is going anywhere. And many of them will just disappear, that's fine. But it definitely was a shift in the company to try and focus on this. Not that they're communicating it particularly well, but it definitely represented a sea change for the company itself. Meantime, OpenAI's continued on, and they get to GPT-4. This is when Microsoft kicks in an additional $10 billion, so they're up to 13, and they're spending it quickly on huge amounts of Azure compute. So there's this feedback cycle where every bit of money that Microsoft puts into OpenAI, they essentially get back in consumption on Azure. And OpenAI just keeps coming up with bigger ideas and bigger ideas to expand the footprint. So it's the spring of 2023. The various Copilots are emerging now. Some of them are being talked about public, some of them are not. And we're still trying to rationalize all of that. And certainly the companies are in flux. OpenAI goes multimodal with GPT-4o. This is May of 24. It's a year later. So cadence is still pretty high. And this is around the time the Chinese appear with DeepSeek. So this is January of 25. It's just this year. I know it's crazy. Just this year. What DeepSeek really said was, we don't have to make everything bigger all the time. That's an American idea, right? That only bigger is better, that more consumption is better, larger data sets are better, that we can actually scale things down and make them smaller, and maybe they're tuned against the larger models, but either way, it doesn't have to be as big as necessary. For the most part, DeepSeek doesn't seem to have made all of that much impact. Microsoft's reaction was just to add it to the Foundry like every other product. If you want to use it, feel free. But in the programming space, because programming languages are more coherent than human languages, we started having some real progress. GitHub Copilot got better, and Microsoft started integrating it throughout their different tools. Today, as of this year, you're able to assign an issue in GitHub to a Copilot, and it'll submit you a pull request. It may not be a very good pull request, because the quality of the issue you write matters a lot, but it speaks to a new model, a new way to iterate on this problem space. And you can see that this is not a solved problem, because there's a ton of tools out there, and they're all of varying quality and potential, right? But this is typically what happens inside of a bubble like this, is that flood of money kicks off many projects simultaneously, all with different ideas, all trying to get to a goal of some kind. And in many ways, they're very similar. They press against each other. And 20 years ago, we would have expected some of these companies to get acquired by other players, sort of consolidate, but that's largely not what's happened. What's happened has been a little more rapacious than that, where companies like Windsurf had all of their senior folks poached by Google with huge 2-digit signing bonuses and basically gutted the company. And when the investors complained, paid off the investors. So like it takes too long to actually acquire the company, so let's just take the assets, the people. You're even leaving the software behind. It's the side effect of trying to move this quickly. And we are, as software developers, sort of looking at what software makes sense today in these new tools. Programming in many ways is still programming. We're gonna have some automation to it. I mean, we have a distinct advantage. If you've been working with distributed source control, you're already used to the idea of code coming from nowhere, from some other source. You've already been cut and pasting from Stack Overflow. You're used to criticizing code. And so the fact that it might be generated by a tool, not that much of a stretch. We just have a new generation of code generators. But when we start looking at other software, it gets more interesting. You know, most software these days is largely forms over data. If you think about an ERP system, somebody working in accounts receivables job is to collect money from those that that company is owed. And we write interfaces over top of that data set so that they know what to work on. But that could also be a prompt. So there's areas of software that in that model are very disruptible. It's just a question of how well we organize our data. I don't know if you've looked lately, but most company data, not that organized. Microsoft says useful things like, you should make sure your data estate is in order. It's like, hey, Sparky, come here. Nobody's data estate is in order. It's like saying, are we secure? Yeah. Right? These are continuums. They're not destinations. You have to work your way toward them. You've been putting off cleaning up your data sets for a long time. You know, on my shows lately, I've been able to talk to folks saying, this was my opportunity when the leadership came and said, we have to use more AI. Like it was a squirt bottle you could spray on things, just like Agile used to be. If we spray people with Agile, things will go faster, right? If I squirt people with AI, maybe it'll go faster. It's like, okay, well, if you want some AI, we have to make sure our data is in state in order, something we've always meant to do and is actually a valuable thing to do. It just isn't new features, so it's harder to measure. So we are in a disruptive moment around software. But the returns, this growth pattern, what OpenAI was promising to the scientists, this idea of we're going to hit an omega point, everything's going to transcend, we're going to make AGI, literally a chant inside of OpenAI. Doesn't seem to be true. The landing of GPT-5 this year, in August, just in August, was sort of an indicator. It wasn't that much better. We kind of run out of data. You know, if you index all of the internet, there isn't another internet to index. Moore's law does not apply here. Plus, what are you doing indexing 4chan? That's just not a good idea. Don't do that. Get that out of there. Sure, it's data. It's just not good data. And so we've started to see this declining return, far smaller improvements. We're starting to hit the wall on bigger is better. And that brings us back to this bubble. Where are we on this curve? I think we're well off the peak. You know, it's just not as shiny as it used to be. Are we in the trough yet? I don't know. It doesn't seem that way. I think we can get grimmer than it is right now. But it also begs the question, is this even necessary? Was this actually what we had to do to build this technology? You know, this was the argument with the dot-com boom. Was this the only way to make the web successful, to put it out there? Why? Why this much hype? Why this much money? And you could blame some of it on the name, right? On the science fiction, on the confusion. But also that there's other motivations out there. Big motivator for many of the largest companies are data centers. You know, we've been using the excuse that we need more data centers because AI. But if you actually go back to before this technology trigger, if you look at the annual report that Microsoft published in 2019 to their shareholders, they said, hey, Azure is growing just fine, but we're having trouble building more data centers. People don't want them. They're large, They're noisy, they consume a lot of power, and they consume a lot of water, and they don't pay very many taxes. So they're unpopular. And then ChatGPT came along, and all of a sudden, AI was a race. It was important. We had to move quickly. We had to be first. It was the changing of everything, and we need more data centers. And the municipalities loosened up the requirements. And these companies were clever. Microsoft doesn't build a new data center. Some unknown company builds a new data center. They build lots of shell companies that do it quietly in many different places simultaneously. In many cases, all they've done is acquired the land and the tax breaks. They haven't actually built the data center at all. They're running low on concrete. They're running low on skilled people to do the work. But they position themselves pretty much to put it out of reach of anybody else ever competing in the cloud space. It's not just Microsoft, it's also Amazon, it's also Google, it's also Meta. All of them have poured money into this space to the point where it's literally distorting economies. The United States now is continuing to post successful numbers in their markets, but almost all of that growth is due to data center construction. The rest of the industries have slowed down, but the billions and billions of dollars that these companies have put into building data centers, by the way, money they have as cash for the most part, because they had such large cash reserves. So instead of doing stock buybacks with these billions, they're buying data center space with them. It's an asset. It's just more turning cash into other physical assets to the point where it's literally hiding the decline of the rest of the US economy. Now, this is going to get problematic for all of us. The S&P 500 is an index of the 500 largest companies by a group of people who decide those things. And 7 of these companies, that they call the Magnificent Seven, last year represented more than half of the growth of the S&P 500. That's what's shown in this graph. The actual overall value of those 7 companies is about a third. So the other 493 companies are only 2/3. That's nuts. 10 years ago, they were already overvalued when they were about 10% of the value of the S&P 500. Now, we're not in America, but the S&P 500 is one of the largest global equity entities in the world. It's about half of the world global equity market by itself. And it's at least 30% overvalued. When this correction comes, we're all going to feel it. There's no way around that. It's too much money, too quickly for us to be able to adjust it. Now, the US is going to be hit harder because the S&P 500 represents about 80% of their equity market. We're all going to take a hit. And folks will argue there isn't actually a bubble. Don't worry, we're going to grow our way out of this. Except that they're doing all of the things that you do when there is a bubble. So Bloomberg recently put up this visualization where NVIDIA, which used to make video game cards, now making these GPUs for AI, has now the first $5 trillion valued company, has started investing in AI companies so that those AI companies will buy NVIDIA products. So I take my $1 billion, I invest it in you, and you spend it on me, and I make $2 billion. Is how you maintain an illusion of continuous growth. And yet, meantime, we still actually have to show value. We have to show results from any of this. And so we cut a lot of corners and we take a lot of chances. You're moving so quickly, you don't think about the impact of the software that you're making. We saw this with ChatGPT psychosis. So the effort to make ChatGPT effective with people, to help tune it, meant it was very obsequious. It always reinforced you. It always affirmed you. And the consequence has been people's personality quirks being amplified into full-on mental health crises. Jeff Lewis worked for Bedrock Investments. This is a large American Silicon Valley investment firm. They've invested in OpenAI and Vercel and a bunch of other companies. And over the past few years, he had been spending entirely too much time with this software to the point where he was absolutely convinced that something is after him. He's having a full-on mental health crisis to the point where he can't work And it's going to take a long time to unwind these problems. Now, it's not like OpenAI didn't know this. In fact, one of the things that happened in ChatGPT 5 was they dialed that obsequiousness way down. They also took all the other models down. When they first put up ChatGPT 5 in August, they shut all the other models off. A, the new model is a bit more efficient, but B, they kind of wanted to deal with this problem. And there was a huge outcry. It turns out people really like their little digital friend. You know, there's just not a lot of difference between the WhatsApp icon and the ChatGPT icon on your phone, except that the ChatGPT icon is always there, always responds immediately, always thinks your idea is amazing. It's always encouraging. That's the best thing it ever heard. And so there was this Reddit post when Altman broke down, gave in, and put 4.0 back up, where people were saying their baby was back. It's software. And it's software that convinces people to hurt themselves. Again, everybody has a personality quirk, but now you've put a tool in their pocket that can really hurt them in the goal of moving fast, breaking things. Just we're breaking people. Meantime, we're going to fix all of this with a super intelligence. Like, we can make mistakes and we can rush along because there'll be this moment where the software is going to solve the own problem. It's the ultimate cop-out because the software is not going to. There's no real image or approach that actually leads to AGI here. We've already hit the limits on the data. We're already seeing declining returns. The real experts in this space, guys like Roy Blatt, and by the way, one of the most difficult books I've ever read in my life. But if you actually want to start to grasp what it would take to really build a superintelligence, this old book will take you a while to read. I had to read a chapter and just think about it for an hour or two. But he really broke down this idea of what cognition was about and what intelligence would look like, more than these tools for reproducing language in different forms. So it's not actually a goal, and there is no escape. We have to live with the tools that we're building. And what we do with them matters a lot. And I'll bring you to 2017, to this video. Audio's not going to show up. Did you remember this? This is Obama. This is a deepfake. This is the original deepfake from 2017. To the point where the voice emulations weren't that good, and so the actual voice was done by Jordan Peele, the comedian. But the animation was astonishingly good. And it was a warning. This is how good the software was getting. 2017, 8 years ago. Today, someone on Twitter can, in a matter of an hour or so, whip together some stills. I think he said, Elliot Higgins said something along the lines of making some graphics of what it looks like for Trump to be arrested while waiting for Trump to be arrested. So these tools are now trivial, simple, easy. And it makes it harder and harder for us to understand what's real and what isn't. The good news is in 2017, which was one of the first times I did a talk like this, I was really frightened of deepfakes. I'm less frightened today because I can already see people being suspicious of what they see, fighting back against it. It's still going to be hard, and we need regulatory bodies to make more progress in this area. There's obvious areas that are easy to work with. We've already got the GDPR. We're seeing the new rules around AI. I just hope they get enforced. It seems to be the real issue here. It's fine to make rules. Just make sure people comply with them. Create real consequences for these large companies. But we can't just leave it to regulators. Not that you shouldn't help them. We are experts in this space. If you get an opportunity to be a part of a process like this with politicians, it's worth your time. It's a good thing to do. But there's a bigger idea here, a larger one that we can deal with because we choose what happens with our software. We've made evil software before, long before AI showed up. Anybody remember Grayball? So Uber, one of the original over-invested in companies. I mean, it's a good idea. The taxi monopolies are bad, right? They really get awful after a while. And so Uber's idea of you'll use an app, anybody can be a driver, you can call up what you want, pretty cool idea. Except that those taxi lobbies have a lot of power, and they went to their various governments and said, you got to stop this thing. And so many places Uber couldn't even get started, but Uber got smart. They added Grayball. It's a piece of software that ran inside the phone app, and it identified the phones of regulators. And so whenever a regulator would pull up their phone to see is Uber in my town, wouldn't show any cars. But if a regular person did, Uber worked fine for them. The only reason we ever found this out is that one of the developers eventually leaked it to the press. Didn't want to lose his job, but he didn't want this thing to not be known about. Now, Kalinick got his hand slapped, and I think briefly for a day, the Uber app was out of the Apple Store. It kind of went away. But they're still around. They're still doing their thing. $60 billion invested in Uber. When you have that much money, you literally cannot make good choices. It's impossible. It's too much money. You have to do crazy things. Cambridge Analytica. We don't hear anything about them today, but let's face it, this is the group that hijacked Facebook and largely made Brexit come true, because they knew what regular people at Facebook didn't know, that they could tailor an ad to an individual, and that individual could not tell they're the only one seeing that ad. This is before LLMs. Imagine what you could do with automation today, using the surveillance information that's available in these systems to literally give you messages to change your opinions. We're in danger, and we're the tool to make those things come true. Now, I want to, before we run out of time here, give you some good news. Let me tell you a good news story. I have one area of AI I haven't talked about at all, and it's DeepMind. Do you remember these guys? Started back in 2010. This is Demis Hassabis. He wanted to make an AGI. He was in video games as a young kid, brilliant, world-class chess player, just a remarkable mind. And so he created DeepMind. He got funding from Google fairly early on, got acquired by 2014, refused to move to Silicon Valley. He stayed in the UK, kept his team there. And he focused on video games because that was kind of his background. And maybe you saw this in the press where rather than teaching the software how to play a video game, it would literally just play itself over and over and over again until it learned strategies. It grew its own strategies to play Breakout very well. Not a particularly important thing, but it built some software that was interesting. And to become more visible, he moved on. DeepMind focused on the game Go. This was a game that was thought of as impossible to automate. And so they built AlphaGo. It took them 2 years of training against all the best games in the world that have been well documented. And in 2017, it beat the best player in the world 3-0, and really upset the Chinese. The Chinese suddenly got very, DeepSeek can pretty much point its existence back to when AlphaGo became the best Go player in the world. They didn't stop there. They went on with AlphaZero. So instead of training against known games, with AlphaZero, they again just had it play itself knowing the rules. So it constructed entirely different ways to play. And it was able to beat AlphaGo every single time. Still not important. So he took that model and moved it on to the next problem, which was protein folding. So dust off your old high school or college biology. Do you remember the 20 amino acids that essentially are everything? Every protein structure of your muscles, plants, everything based on these things. And these various aminos combine together and twist up, right? They form into long chains, and then various electrostatic forces and hydrogen bonds and things fold them up into ways that are almost impossible to understand, and yet are vitally important. Figuring out one structure of a folded protein like this, the one from myoglobin, the thing that carries energy around in your body, took a scientist named John Kendrew 12 years to figure out. They gave him the Nobel Prize for it. Over the past 60 years, tens of thousands of scientists have worked out about 150 proteins. And the problem is that there's so many different ways for these proteins to assemble together and fold that at one point a mathematician did the numbers and said a 35 protein chain, which is not a particularly long one, has 10 to the 35 possible combinations in folding spaces. Some of them are actually impossible, but It's just too many options. And so in biology, they started a competition. There's a theme here. It was called CASP. And CASP stands for Critical Assessment of Structure Predictions. So scientists using this thing called X-ray crystallography were slowly able to figure out particular protein folds. And it took years and tons of effort. The question was, could they build a software model that could match that? So they started in 1994, and they got up to about 30–40% accuracy, and it just sort of sat there, didn't really make any more progress. At one point, they even made a game called Fold It that allowed video game players to experiment with different folding strategies, which after a couple of years actually figured out a protein. And an important one, the aflatoxin protein, which is the protein that causes disease in plants, like ruins corn crops. So really, now that we know that protein, we're making whole new sets of treatments to stop crops from being destroyed. So in 2016, DeepMind built AlphaFold AI. So again, taking that model and applying it to the protein folding problem. It took them 4 years. By 2020, they were at 90% accuracy of what a protein fold would look like. Now, they're owned by Google. This is an incredibly powerful product. So what would they do next? Their answer was to figure out the protein foldings of 200 million of the most common proteins that exist and give them away. They've ended the protein folding problem. The problem that scientists now have is they know so many different proteins, they just have to work on this. But already, this is only a few years ago, we can directly point to that protein folding data for a new malaria vaccine, for beating antibiotic-resistant bacteria. So they gave it away. They chose to solve a problem with humanity using generative AI. And we can choose also what is the world we want to make with these tools. It's up to us what we choose to do with it. There are plenty of ways to harm us. There's also plenty of ways to make a difference. We just have to choose.